So now we will have a panel discussion, and we have invited four participants for that. They are all working on these LLM-driven climate services. So I hope that you find this discussion very interesting. What we will do now is that we will allow each of these speakers to present their work in 5 to 10 minutes so that you get a little bit of context of what they are doing. And we will have time to ask questions to them, and then we will revisit the questions that you have asked in the interactive activity with Stacy. So the first one to speak in this session is Arno Schall from Web Lizard. So Arno, if you are ready, the floor is yours.
Good morning, everyone.
Hi Arno. We cannot see your camera, but we can hear you. Yeah, there you are.
Okay,
Thanks.
good. Good morning, everyone. I'm glad about the opportunity that I can today present you some of our recent work, which is actually being done as part of the Climate Europe 2 project. And let me see if I have the right to share my screen.
Yeah, everything good.
So what I'm going to talk about is, there are manifold applications of artificial intelligence, both in terms of as we see it in daily workflows, in processes, in software development, in climate services, also in terms of optimization problems. What we have been working on for the better part of 20 years is analyzing the communication layer. So stakeholder communication, the public debate. So everything from professional publications, scientific articles, to government documents, regulations, news media, and on the other side of the spectrum, community forums, social media platform. And with the idea to extract insights on the one hand about how different stakeholder groups, how different communities approach a topic, why there might be communication problems. But on the other hand, also to connect disjunct information and provide a unified view on it, because so it's the discoverability. Uh, Plus, I think you all know the concept very well. We have uh, the phenomenon that's called as filter bubbles, which is that we are only seeing our worldview, which is always reflected back and forth, and we're really um, blacking out all the content that others are publishing, which is most evident in political processes, but also in contested environmental issues, for example. So our goal with our platform is to do both. So to integrate information by the use of AI. We use hybrid AI, so neurosymbolic AI. So we have both the structured part of AI, a knowledge graph, where you have entities, organizations, locations, and persons stored with a lot of metadata. And then we feed a lot of content on a daily basis into the system from all the said sources. So everything from government resources to social media posts. And the specific application you see here, it's available within the Climate Europe platform publicly. But I'm also going to show you at the end of my talk a slide with my email address. So we invite you also to try out. There is like a feature with login where you can have much more richer functionality. That's what we can show here publicly. And I think I'll just show you a few slides to give you a feeling of what the type of things we can do. So, for example, climate services as a concept, we can now look as well, which are the different sources that are actually talking about climate services, that are publishing relevant content about climate services. I mean, maybe this type of layout looks familiar. We actually were developing this in another project with journalists from the French press agency AFP. And they said, TweetDeck was one of their most used tools in their daily work. So this is a bit inspired by those of you who still know TweetDeck. It doesn't exist anymore, but then we are automatically classifying the content in the different streams. That's also a thing you can do with AI classification. So to structuring information into different aspects according to metadata dimensions, geography, time, different topics, uh, is what AI is really excels. The second application of AI that's also built into this platform is then the condensing of the information. Um, this query resulted in 150 documents. You might not have time to read 115 documents right away. So the system has a built-in AI summary feature. So these tabs on the lower end that now summarize me by country, and I can take any topic up here. I can classify it by SDG. I can classify into adaptation and mitigation. I can classify, as you see here with countries, or as you saw in the previous slides, with sources. So this is really flexible. It generates then the summary, and you can see on the right side, you can also tailor the summary. You can say what type of content you want to focus on in your summary, and also what style it should generate. What we're trying to do here is to combine the best of both worlds, to have the flexibility of prompting. So in chatbot, you can ask any question, but then you get text output. So we want to combine the flexibility of a conversational interface with the power of a dashboard of visual structures that are much more suited to convey complex information. A few other things you can look, speaking of geography, the system is able to map all the content that's being ingested geographically, and then a drill down. So in that case, I clicked on Spain, then it does a drill down on only those parts of the information space that mention Spain or one of its cities. This is another query. I've restricted now the sources to only research and government. So these are the websites of research organizations, universities, and government websites. And then it tells you which were the organizations that in the time interval that have chosen for that query, that was since last October, who were publishing most on the concept of climate services and climate information. That's international now. The system also provides various ways to restrict this geographically and say, only show me this for Europe or only show me this for a particular country. What I've shown you here is the light version of the dashboard. It's responsive, so it's supposed to be used for content exploration, can also be used very effectively on a smartphone. We do have a professional version of the interface that is much richer in functionality, and it also has a nice overview here what sources that go in. We have the various web sources, we have scientific publications, integrated press releases, and also the information from fact-checking sites, and it's also available in multiple languages. So if you query something, you can automatically pull together the content resources, not only across organizational boundaries, but also across languages. And that would be another example. This is just purely now on scientific publications. It was a query since the start of the year, climate adaptation. So we got 518 scientific publications that mention climate adaptation. I picked the classification by SDG. So we take these 518 documents that talk about climate adaptation. We see, well, which SDGs are prevalent in these documents. And then you can track things over time, what topics were being discussed in these papers. You see the list of papers sorted chronologically and the various types of visualizations that then try to give you an idea, like in the Tech Cloud, what were the major topics associated with climate adaptation by that group. So this was just meant to give you like a very quick overview of the type of things. As I mentioned, you see my email here. We do run more focused webinars in regular intervals. So if you would like to join, gain access to the dashboard and get a bit of a deep dive into the various features, We're definitely organizing one in next month or two. That's all from my side. Thank you.
Um, Thank you, Arnold. Again, you will have the slides uploaded briefly after the event, so don't worry about taking screenshots or remembering his email. You will have it available after the session. Is there any quick question? I guess there's a simple one for you, Arno, in the chat. Maybe you can take it directly there,
Mhm.
and we can move on to the next speaker. So the
Yes,
next one, yeah.
we do
Okay, yeah,
have
go ahead, go ahead.
we do have API access, so the content resources plus the metadata. So we have a whole API framework. So if you email me, we can also share that with you.
Okay, thanks. So, if I'm not mistaken, the next speaker on my list is Jonas Sostin from Development Seeds. So Jonas, the floor is yours whenever you want.
Yes, let me get Zoom to play with me here.
Yeah, we can hear you, we can see you. We don't see the presentation yet, but it's coming.
Perfect, thank you.
Yeah, everything ready. Thanks.
Awesome, thanks. Yeah, so thanks, Arno, for kicking us off in the panel session here. My contribution here is about a project that I'm overseeing from my role at the company Development Seed, which is a US and Lisbon, Europe-based company. So we have two entities. And we're working with the ECMWF on the Destination Earth initiative. And as many of you know, ECMWF has been developing digital twins, which are really high resolution climate models, and for both for climate adaptation and for extreme events. And these simulations are quite novel, and the data volumes are huge, as you're also familiar with. And the challenge is that we want to make data discovery and access easy to these tools. And so our project mission is is to increase the use of these digital twins by scientists and climate analysts in Europe. And the goals that these target users have is that we postulated is that we that they want to learn about the digital twins. They want to get familiar with this as a data source because it's quite new, not unlike ERA 5 or the CMIP 6 or so, which are really canonical at this point. And they also want to get started with data access. There's some novel patterns that the Destination Earth platform introduces, and then maybe also get a first feel for the data and make some data visualization directly in the app. The main challenge that these users are facing, which we actually also face as developers when starting to onboard to this, is you need to be very specific about what you're looking for. If you know what parameter, what model, then it's actually not that hard to get to the data. But if you don't know these things, what even exists, and so on, then that's quite hard. And we also talked about the possibility to go beyond giving access to the data and actually like recommending even which data sets to use for a specific application. We heard the potato use case previously from Climsite, which like should I grow my potatoes in this region in these decades to come? This is something we explicitly excluded from our project at least because for these new climate simulations, we were just lacking the fitness for purpose information to base good recommendations on. So just a brief overview of our process, if you're curious. We had about a year to work on this, and we're soon ending the first year here and preparing for a beta launch. So then it'll also be available to all of you actually to try out. Um, and we spent some time on discovery and understanding the scope here. There's a few people on our team who have a background in physics and science, but we're also a lot of software engineers and really need to bring everyone up to speed. Um, And then we worked on developing the tooling for this AI application, and then refining the application now towards beta release. We have a team of 5 people with like AI and cloud engineers, front engineers, and designer and a product owner. So that's our small project. And as I mentioned, the starting point is basically that these users face these big forms to fill out, or lists of parameters and validation data and all kinds of things. So that's kind of, if you're new to using climate data, this is kind of the wall of decisions you're facing. And yeah, the question is really how to address this, and I want to quickly contrast 2 approaches here. This is actually very similar to what Ivan showed earlier. I found this distinction really nice that he showed. Let me see if I can just pretty quickly switch tabs here. Yeah, I'll do that. So if you remember this slide from Ivan's presentation, distinguishing the early stages of LLMs that just spat out some random stuff, then the assistant type with very controlled output, and the agent, which do a lot of things on their own. Our project is kind of in the middle box here. So we're building a scientific data discovery assistant and here, the way these applications are built, you have an agent, which is basically the large language model that makes decisions, and then you have tools that this agent can use and it decides it's on its own when to use which tool and how to combine the outcome and so on. And in this scientific data discovery assistant, we have an agent that knows language, as all LLMs do. It has some instructions from system prompt about what its purpose is and what to do, and also what it might use these tools for. And then it has some inherent domain knowledge. We don't know, right? We heard in the talks, the last presentations about LLM-based validation, how different these models are in terms of yeah, in terms of what inherent knowledge they have, and BSC has done a lot of work on that. And they have, in the end, they have limited context. So basically, they can surface literature and technical documentation. There's this RAG, retrieval augmented generation principle. They can find scientific parameters for some vague specification. If you say precipitation, it'll show you total precipitation. It will show you like different forms like snowfall and whatever. And it can query the data catalog and give you concrete data samples you might want to extract. It can also operate a data extraction APIs to give you actual data and produce templated code for running these things on your own. And in the end, these things are what's possible. And this is an assistant to make them more possible, basically, for you as a user. And in contrast, Cloud Code, everyone's always like, wow, I built this great thing with Cloud Code, right? So I use that as a synonym here. And this corresponds also to the third stage that Ivan talked about, which is basically we have it's actually very simple, right? It's again an LLM that knows language and it knows Unix as well. It knows how to code. This is all big LLMs know that basically, and everything becomes context in a session. It can run these super simple tools. I'm oversimplifying here, but it can search for text, it can replace text, and it can write code, and it and then there's the addition of skills and so on. I won't get into that, but in principle, it just operates these very simple tools and builds a lot of context in the session from all the things it reads. And that's all it needs to know, right? It needs maybe to know a bit of inherent knowledge, but mostly everything you need to know is what you built in your current session, which is your code base or whatever. And I think and with these simple tools and few constraints and leaving all the context to the LLM, anything is possible, right? It can build anything. It can also destroy your computer or do all kinds of stuff. But in our case, we wanted to focus really on a much more constrained set of things to do, also because for ECWF trust was a super high criteria. So we want to take short steps, small steps first, and add convenience, but not yet full agentic experience. Yeah, and how that looks like, you'll see the real thing soon. I hope you'll follow ESMWF and Destination Earth publications, and you'll see the announcement soon where it's a conversational interface that also produces plots and helps you get started with these catalogs. That's the quick overview from us here. Thank you.
Okay, thank you very much, Jonas. Sadly, we need to move on, but you will get questions after the rest of the speakers have presented. So thank
Thank
you very
you.
much. The next one is David Tolke from RWTH Aachen. So David, you have been mentioned quite a few times already. The floor is yours.
Yeah, thanks. So just a bit for me. So I'm currently wrapping up my PhD at RWTH and also work at EPTech as a basically LLM scientist. And also today I wanted to talk about climate GPT, what was mentioned quite a few times already, and basically some a bit follow-up work. So yeah, you see the slides, right?
Yes, we see the slides. We can hear you. We see you.
Perfect.
Everything is good.
Okay, so basically, I think also falls quite nice into this, kind of three phases that Ivan mentioned. So first, climate GPT. So the goal was to develop this domain-specific climate LLM, which I think still mostly falls in this first category, where we kind of was also around the time where we take LLMs as a kind of oracle still, don't provide it too much context, and wanted to just see, okay, can we kind of improve the climate knowledge that this model has? But then basically afterwards, as well, we notice for a lot of cases, these models do hallucinate and we need to include some additional context. And that was basically the motivation then for this follow-up work that I will talk later on. That was also mentioned by Ivan actually, where we then said, okay, how can we then, if we have some external context to the model, actually validate that this context is used? And then we saw it's not perfectly used and how we improve the usage of that context. Yeah, but first about climate GPT. So this was mostly developed during 2023. So we kind of started, mid 2023 working on it. So the main phase of the project was kind of 4 to 5 months. And the goal was really to develop this climate domain-specific LLM, which has more knowledge on climate-related concepts, where we had a quite broad definition, kind of ranging, I don't know, from knowledge from IPCC reports, but also then kind of social, economic factors. So all areas that are kind of scientifically related to climate. So it was a joint project from EPTech, Erasmus AI, which is a Dutch company that does a lot of analytics and has provided us with a lot of the data that was used in the project, and this American startup Equity Lab. And then the kind of initial goal of the project was also this demo application, which is was this multilingual question answering chatbot that we also then demoed at COP28 and 23. So to go a bit more into detail, how do we then actually build this domain-specific model, and also to go a bit more into detail into LLM training, what wasn't discussed too much today yet. So in general, in LLM training, we have kind of these two phases. So first is pre-training phase, where basically traditionally most of the compute is spent, and you just train these models on vast amounts of data, quote from the webs, on papers, on source code, and so on. So really just kind of unstructured data that you can get, feed it in the model, and you kind of hope that the model then learns patterns, learns information, kind of learns knowledge out of this. And then the second phase, you have this instruction fine-tuning phase, where you then actually have really prompts and outputs. You kind of really train the model to behave kind of like an agent or an assistant, so that you can give it some instructions and you train the system to actually follow these instructions. So what did we now do for this, for the Climate GPT project? So first we just had limited compute budget, so we trained some smaller models from scratch, but the actual models, we focused then on continued pre-training, meaning we started at the time with the Llama 2 models for Meta, and trained them on additional 4.2 billion tokens, so around 3 billion words of climate-related text. So as I said, literature in the relevant field, also some selected news articles, and so on. So kind of that was really curated with quite some effort from Erasmus AI to kind of cover kind of, most of the stuff that's credible and that you can get publicly, but which is still compared to the total training data of LLMs a small amount. And then for the instruction fine-tuning, that also mentioned that we worked with a lot of climate experts, to really get some high-quality answers for climate-related questions. But we were mostly focused on this kind of simple question answering style. So you have basically some document and ask some questions about these documents. Then for benchmarking, we worked also a lot of these more simple climate-related benchmarks for the evaluation, which I also mentioned, but these are really kind of simple. So simple things like kind of fact-checking, is this climate-related fact true or not? Some simple multiple choice questions, but here we got really some nice improvements, but to be critical, a lot of these benchmarks don't measure a lot of things that are then really too relevant for the actual scenarios we want to use these models in. So for example, in a lot of these multiple choice benchmarks, if you look at it just by common sense, the answers are often kind of clear and you don't need too much climate related knowledge. So I mean, still nice that we got these improvements here, but I mean, benchmarking is still a huge issue. And these models are also available on Hugging Face if you want to use them. And also Erasmus AI is kind of still maintaining this and has a newer version of this on climategpt.ai. Then for the second phase, I mean, there we mostly, again, focus on kind of improving the knowledge of the system by this continued pre-training. And then only downstream kind of used it for RAG. And in this initial phase also didn't really put too much thought into optimizing the model for this RAG use case in instruction fine-tuning. So maybe quickly what we mean here by RAG, you have some input, then you have some retrieval system that from your knowledge base, which for example could consist of IPC reports, relevant papers. This gives you some context, which is then given to the LLM and it generates a response. And here in this kind of setting, you really want that the LLM just uses information from this context and does not invent additional information that the model thinks is relevant. But actually, if we kind of train this here on human data, humans really like to do this. So they get some sources, but they always also add some information that they think is relevant in addition, but which is not really clearly proven from some specific context. And then if you train an LLM on this data, you clearly see that it kind of mirrors this behavior and starts to invent a lot of stuff. So kind of how do we address this? First, we kind of want to kind of evaluate which part of this is faithful. So faithful here really means facts that are supported in this given context and not factual. So meaning we're not directly interested whether an output is correct, but focus first more on basically is it grounded in this context, because that is easier to evaluate, and whether it's factual in general is a much harder question. So how we do approach this, we take this response, decompose this into smaller kind of atomic claims, which are then easier to verify, because such a long response is often a bit too difficult to evaluate in one go. And then this whole pipeline we also validated with human evaluation and checked that this works really well. And then we had basically this as a starting point and noticed, okay, the faithfulness of our climate GPT model is kind of really low. So how is this happening? And therefore, we then could look more into this, our training data, and saw that actually some part of our human export data also had quite low faithfulness. And then by correctly preparing this data or filtering this data, we got quite a huge improvement then in faithfulness. And also with this model, also we see quite some improvements then in general in factuality from here 57 to 69% when using RAG. But here also take this with a grain of salt, because then here factuality is measured against a limited knowledge base. And I mean, non-factual just means we can't verify it in the knowledge base, not that it's not correct. And then finally, kind of to get through this last point, wanted to give some points, kind of what I see as an outlook. So today, modern LLMs like, I don't know, Qwen 3 or Gemma 4, they're trained on much, much more data than basically Llama 2 in 2023. And this also kind of means that this kind of continued pre-training on climate data becomes less relevant. So we kind of try to repeat this on Llama 3 at the time and saw much less improvements from this continued pre-training because these models saw so much more data that and seemed to learn much more concepts that this kind of limited 4.2 billion tokens didn't have such a large impact anymore. Also, then nowadays, LLMs are expected to handle much more and more complex tasks, like all these agentic workflows and so on, so which goes beyond simple answering a question, and also kind of because that these post-training instruction fine-tuning, both the data and methods become much more complicated. And the problem is you want to do this pre-training or continue pre-training yourself, you also kind of have to redo this post-training. And this is also still something that's very difficult to get high quality data and kind of still the kind of secret source of the big LLM providers. And yeah, otherwise you have to resort to a lot of synthetic data, which also has some problems. And then also this general trend, which goes in the third direction, kind of with LLMs moving more and more away from relying on the parametric knowledge of LLMs towards these LLM agents that basically know how to retrieve, process, and verify kind of the knowledge they need. So for this, you need some kind of understanding of the domain to kind of know what to search for, let's say. But maybe they actually don't need to know too many detailed long tail facts anymore because since models know how to retrieve them. So basically these more higher level capabilities are then needed. And basically, as we also discussed before, this really gives a benchmarking challenge. So a lot of these climate benchmarks are really quite limited in this sense. So there was also a really nice paper at ACL last year, which actually showed that a lot of these climate benchmarks actually have some, really some issues where the ground truth is not annotated correctly. And then especially in the context of climate services, they're really kind of lacking benchmarks to benchmark these higher level capabilities. And I think really also to make progress, really good benchmarking is really important. I think that we, for example, saw, for example, in coding agents. So there for code, we really know how to benchmark stuff. And because that also made a lot of progress recently. Yep, that's it what I wanted to say.
Okay, thank you very much, David. So okay, let me check the chat. So I think that's a quick question for you from Alicia. I will read it to you. So in the fact-checking evaluation, you said you decompose the answer in claims and then check if the claim is in the context. Technically, what are you using to check if the claim is in the context?
Yeah, so here we tried a few things. First, smaller BERT models that are kind of trained on this fact verification task, but then we actually saw then that in most cases, a large LLM actually performs better on this, just because then probably the training data might not be a perfect domain fit for these more classical fact verification models. So at the moment, kind of the standard pipeline that we had in the paper then uses, I think was GPT-4.1 at the time. But there, if you want to deploy this more large scale, there's also something where I think synthetic data can be quite helpful to use synthetic data by a large LLM and train a more efficient, smaller BERT model to, kind of reduce a bit the resource usage. I think the important thing here really is that this checking of a small claim in a given context, that is a much easier task for these natural language processing models. That works quite well.
Okay, thank you very much. So we will now move on to our final speaker, which is again Ivan. So Ivan, I don't know if you have prepared an additional presentation.
Yes, I have.
Okay, so the floor is
Let
yours.
me share the screen. Okay, can you see it now?
Yeah, thanks.
Cool. Okay. Okay, let me just so hi again. And now I want to give a short overview of two LLM-based tools we are developing at Ivy. the ClimSite and the Pangea GPT. I will keep this practical and not to go deeply into the technical details. The idea is to show what those systems do, how they differ, and how they fit into our current direction. And Jonas explained very well how the system works. So we use a very similar approach, but our user interface and software are not so advanced. And we can also use models like those shown by David, Climate and Loopy, and by Mice and Alice, but for background for our application, but for developing simplicity, we mainly use OpenAI and cloud models. ClimSite starts from the location and natural language question. For example, the user can click on a place and ask something like, what should I know about climate conditions here? Or what risks should I take into account? What is important is that the system does not only look up climate data directly, it first uses reports, articles, and other text sources to better understand the background of the question and what kind of context is relevant. Then, based on that, it retrieves the climate information it needs. This includes climate model data and also RFI for analysis data. And after that, it can run analysis automatically using Python scripts. So it's not only retrieval and summarizing, it can actually process the data, generate the plots, and assemble the results into a report. The output is a report with the links to the sources, of course, that were used. And the user can also download the data products that were generated or retrieved during the workflow. So the main point is that ClimSite connects the background knowledge, climate data access, and automatic analysis and report generation in one workflow. The Pangea GPT starts from a different entry point. Instead of location, it starts from a scientific question. Its role is to work with the geoscientific archives, especially Pangea, where there is a very large amount of curated data, but it's often difficult to find the most relevant data sets quickly. So the system helps with this in two stages. First, it searches the archive in the agentic way. That means it does not just do one keyword query. It can inspect results, formulate the research, and narrow down to data sets that are actually relevant to the question. Second, once the data sets are selected, it can continue the analysis. Different agents can handle different kind of tasks, for example, gridded data, tabular data, plotting, or summary generation. Again, the key idea is that this is not only a search interface, it's a workflow that goes from question to data discovery to analyze and to figure and interpretation. This is also closely related to our broader direction because the same kind of agentic workflow, Python execution, and self-correction logic can be reused across different scientific tools. Here I just show two examples output from the Pangea GPT work. I already discussed those examples in more details earlier today, so I do not need to repeat the full story. The reason to keep this slide is simply to show that the workflow really ends in concrete analysis products, figures, comparison, diagnostic. And at this point, I switched to the a shared demo video for both systems. What I say before starting is that we are gradually bringing our LLM-based workflows together under one interface. I hope it works. So we start with the Pangea GPT, and so we ask the system to find like a 5 most relevant meteorological observations data sets from the Mosaic expedition. It makes search, pick up the 5 like most relevant thing the data sets, provide the publication it uses, and load to your computer. So you download the data, and then the system start to like analyze, and then we proceed to the next agent that use those data that have found and make a request to make like a figure and make some basic statistics based on those data sets, so describing in details what we actually want, right? So, and it provides some explanation and then produce a figure like this, so with the details and then quite sophisticated figure that's ready for the publication already. The next one is EURUS. It's mainly linked to the R5 data. So again, the system we ask the question to get the data for like temperature, air temperature at certain point. It download the data for you and make some simple analysis like a trend analysis. And we can continue with the same logic and ask one more station, and it download the data and make some simple comparison of those two different points. And the next one just ask to download and make a comparison between two time slices. So our request was to compare the two time slices, and it's did its job and provide some statistics. Now switching to the CLIM side. Again, so for the CLIM side, we ask a question like what we want to build a wind farm here, or we have already wind farm in Canada, and we want to analyze what kind of problems we can have, what kind of risk with the icing, for example. And then the system start to look for the relevant publications, even in the Wikipedia or some publications, ask for the data from the ERA5 data sets and the Destiny data, and then provide you like local context, current climate baselines, reports that are like the system thing most relevant to your question, and also some risk assessments and practical recommendation, again based on the ideas of the LLM itself, right? And based on the data. And then, of course, you can download and look on the figures that it used to make its analysis. And you can also download the data that it downloaded itself and get all the references. I mean, the system, of course, works much slower than I showed. The video is very like a speed up. In reality, it could take from like a couple of minutes to maybe half an hour, depends on how fast you can download the data and how fast the LLM will respond. Okay. And just to summarize, the CLIM site is mainly about location-based climate question, and while OpenJGPT is about scientific data discovery and downstream analysis. So our current focus is increasingly on automatic data search and automatic data processing, and also on automated search for new numerical methods for climate models. Yeah, thank you very much.
Thank you very much as well. So I think we will call Stacy and try to get some questions from the mentee in a very biased, handpicked way. So totally transparent. So Stacy, are you able to go back to the mentee and maybe show us some
Yeah.
questions?
There we go. There's 9 questions in total.
Okay. Do you want to handpick yourself? Or should I?
Me? You go for it. You go for it.
Okay. Okay, I'm just going through them. Okay, so I think I'll start with the first one, but I will modify it a little bit. So we have seen that some very popular LLM models have been mentioned in your applications. So there was ChatGPT, there was Llama, there were other models, but we also heard during Marina's presentation about the legal aspects of AI in Europe that those models that have been trained on data that was not legally retrieved are not allowed, right? So I would like to pose this question, like how dependent are you on foreign models right now, and how are these going to impact, how is this regulation going to impact your applications? Like, for example, let's say that the commission says that ChatGPT is not allowed anymore because it has been trained illegally with data that was not shareable or accessible. Would this impact a lot your applications? So this perhaps my first question to you. Yes, Jonas, go ahead.
Yes, so I think not so much. We're not so dependent on these providers anymore. As we talked about, the focus is really shifting away from these gigantic models that have been trained on all kinds of fancy stuff and maybe illegal stuff, to having a lot more logic in these agentic systems and the tools you provide and the knowledge bases you create, like in the case of the climate lizard and so on. So I think we'll be a lot less dependent, and we already can use European models and responsibly built models right now, I think, for these type of applications. That's my take.
Okay,
Yeah.
thanks. Does do others want to add anything to it? Yes, David.
Yeah. So maybe one point, I mean, the problem I see is that also for a lot of the European models, so I think Mistral being the biggest one, I mean, they I think have the same issues as far as I know, that the training data is also first not transparent, and I would guess also if you look on the details, there are some legal issues. I think the only really project I know of is Asperatus model from or was something similar from EPFL, where they really focus a lot on creating legally sound training data. But unfortunately, if you look at benchmarks, this doesn't perform that well. So it's not really competitive than, for example, Mistral, also the leading cloud models. So I feel also for the agentic workflows, so for the models that work well in these agentic systems, even if they're smaller, we still have these issues and they are quite dependent. And I think then it's really a question how strict you see the AI Act. But then if you look at this massive web core data, I mean, that's really difficult to check whether on the page there's some restriction on the use.
Yeah. So, Arno, Ivan, how is it from your side?
Yeah. I think if I mean in such a strict question, if the ChatGPT will be banned or cloud they will be banned, I think we will. I mean, I'm here with the Jonas completely that we mainly focused on agentic systems that are independent on the models themselves. But of course, I think personally we will lose some productivity, I would say, in this case, of course. So it still be possible to work, but it would need us to maybe slow down a little bit.
Okay. I would like then to ask you a question about infrastructure, which is related more or less to the middle question on the left. So you have shown applications that require a lot of computation, right? And is there a fear that if these applications scale up or get a lot of users, there might not be enough computational power to to respond to the demand. Let's say you have 100,000 users asking for agents to process data and make calculations. Do we have the infrastructure to sustain such a demand at the European level? Yes, Jonas?
Yeah, I think I would really hope that we build systems that are modular in the sense that users can pay for some of the analysis themselves, right? Right now, I think in prototyping, we let online systems do a lot of the work basically. But if you provided skills or MCP, and the future variants of these, and others basically run them in their system, then the capacity scales with the number of users basically, and you don't need to pay for all of that. But it really depends. If you want to provide, we know that from computing, right? If you want to provide people with the ability to analyze terabytes of climate data, there's cost to that, of course. And it has been, and it's the same now. So, Arno?
Yeah, go
I
ahead.
just wanted to add for the work that I presented. Our platform is quite agnostic to the actual type of LLM, so it's, I guess, as some of the others. I mean, when our system is mostly retrieval augmented generation, so we have done some retraining of models as well for specific tasks. But the majority is actually coupling the metadata we extract from all the content we ingest with the capabilities of large language models. And that decision, which language model to use, is under constant revision and changes all the time. And of course, we also prefer language models that are trained on open sources and that are responsible. But I think the challenge is then to have actual models that qualify for that provide the same level of performance. I mean, I think this is, I think, a trade-off that we are facing. And I mean, I guess many of you have followed, what Anthropic's new model is has found like thousands of vulnerabilities in 25-year-old software. So for some things, then you need to be the fastest. So it's a very hard decision also from a laboratory perspective. That Yeah, I think it's a decision we don't have to face because our platform is agnostic to it. But I think that's definitely something that is it's from my side an unresolved problem because this trade-off hasn't been solved.
Okay. So do you have any suggestion for that?
Not an easy one. I mean, it's a combination of technology and investment and regulatory approaches. And if it means that you follow all the rules, but then you have, maybe another country, another region that has something that is more powerful, that actually can bring down all your systems, you have a problem. So I don't have a solution for that. I think it's a major problem right now. And I mean, for those of you who follow the Anthropic stories, they're working together with the big IT vendors to fix all these critical vulnerabilities. But
Yeah.
what if someone else would have that model first that would not work with these companies to fix the issues, but rather exploit them? So I think that's a real danger we have to face. And I think there is some trade-off here in terms of, I think it's a huge challenge that I don't think it's solvable in a very short run to have a system that's the most powerful one, but at the same time follows all the transparency requirements because that creates additional overhead. So I put it more on discussion because the model training is actually not our expertise. As I said, our expertise is building solutions on top of these models. but I would definitely encourage and support here European initiatives. But I think there's not a lot of time for that race.
I see. Yeah, I think I mean, the discussion of I think it's mythos. The name of the model is very interesting. Fortunately, we need to come back to climate services, um, since the topic of today. I wanted to ask you, um, what's the role of metadata in your whole chain? Because we usually talk about data and we disregard how valuable metadata is. And I guess that Arnold, for your tool, or David as well, Ivan or Jonas, I mean, you're trying to provide a sense of quality. I mean, you're essentially providing scientific information. I don't know if there's value in the metadata that you're still not seeing and would like it to be there. Do you have any request for the community to improve the metadata? Is there something that you would like to add in this sense?
Should I start? Yes, I
Yeah, go
think
ahead.
the value of metadata is huge, and I think also the presentations we saw today. I mean, Jonas one, so we have also these different types of systems, right? One is focusing on the communication aspect, the other one on the indicators and natural processes, and if we want the best decisions, we need to understand both. We need to understand the ecosystem, we need to optimize systems, but we also need to understand the communication processes and how things are then framed in the debate. And only if you master both, you will have the best decision and also have the acceptance to get these solutions rolled out. So I think in that case, metadata is a key because I was just thinking when you presented this, by, for example, adding a geographic map, and then we have our knowledge graph with all the locations that map everything to OpenStreetMap and GeoNames. We can seamlessly integrate the systems just on this meta level, and we don't actually need a full system integration. So that would abolish a lot of integration efforts that otherwise would not be feasible. By using metadata to connect disjunct data sets, data services, but also completely different types of applications.
Yeah. Would you like to add anything to it? Yes, Jonas?
Yeah, as I mentioned, something we would really have liked to do is to go one step further than basically helping people find data sets in the catalog through some fuzzy matching, right? But even be able to recommend what to do with data, with specific data sets, right? And especially if you look at even if the CMIP flight of models and all the different types of simulations run, you need to be an expert to know when to use an ensemble mean and when to do what and of all these data, and that can in principle all be in very declarative or descriptive metadata, right? And if we document and especially fitness for purpose like that, then all of a sudden this expertise becomes accessible to a lot more people through these LLMs because they can digest it. That's actually an upcoming topic we hope to work a lot more on in the future.
Yeah, I guess one of the main hopes is that all this knowledge becomes more accessible, right, and democratic in a certain way. You don't need to be an expert on everything. You can remain an expert perhaps on climate without being an expert on coding yourself, and that's also fine. Ivan, do you want to add anything?
Yes, it's to add some to discussion about the metadata, as we are very related on the um, climate models and the output from the climate models. Most of the cases, for example, it's MIP6, they do not provide like a very good description of what they have actually there and what kind of types of variables they are. And I think Jonas can agree with me that it's very painful for the LLMs to go through the list that this very poor metadata in there and try to catch what you're actually looking for. And for most of our, let's say, projects, we even do like like extending first to extending the metadata. So we go through all the metadata in the data sets and ask LLMs to make it more readable for the LLMs based on some backgrounds of, for example, model descriptions and so on. So that kind of things are very critical for the such systems. Because the LLM cannot choose by feeling. It needs some information, and this information is usually quite poor nowadays.
Yeah, I guess then that you would say that metadata standards are still very useful. So not everything needs to be created by LLMs, but also perhaps the community needs to invest a lot on creating standards of metadata and provenance to help the LLMs more smoothly find what they're looking for, right? Jonas, for example.
Yeah, just want to say sorry, Ivan. I think the value of human expertise gets even larger when this information then, or like we unlock the value of that a lot more when we make that information accessible, right? Because if we have authoritative guidance from a scientist with a lot of background, or even if in the future a very, very smart agentic system that can do all the inferences and so on, but we have a curated body of recommendations, and that becomes available and it's not just locked away in a paper that's published somewhere in a very niche journal, then I think we that will be the distinguishing factor to applications and also an edge between competitors if you have access to this high quality information.
Yeah. Ivan?
Oh, I think it's fine.
Okay.
Not yeah.
So I wanted to also continue with the discussion of the ground sources or the ground truths that you use to build your models. And I guess one of the questions, and I think it was also posted in the chat, is what do you consider to be trustworthy, and why? And because the fact that it is not AI generated doesn't mean that it should be trustworthy, right? So when you're building your database, you're also filtering out of content out, you are accepting out of content in. And how do you then, what rules do you use to determine what is trustworthy or what is not?
I mean,
Yes,
can say something about what we did. I mean, so for climate change, we kind of had two approaches. So first, for the pre-training was a bit much wider, so that we basically included first everything that is kind of relevant. But then for this retrieval data set, we really then focus on very high quality sources, so IPCC reports, selected journals, really peer-reviewed conferences, and so on. But I think this is really, I think, one of the open issues, and also as we see much more, AI-generated content and much less human-generated content in general on the web. So how can we really build trust here, see what kind of content is really trustworthy, and also kind of connected to, it goes a bit in the metadata direction, kind of connected with future research to still understand what is still relevant, what was kind of superseded by future work. And I think this is still an open problem where we need some project like knowledge graphs and but also some kind of human information on trust in this sense.
Okay. Arno?
Sorry, I was muted. I can only underscore that. I mean, from our perspective, from the communication, as I said, we have other projects where we work a lot with journalism. it is about sources and it's the credibility of sources. It's about establishing the provenance, because we will soon have if it's careful analysis, it will not be obvious if this is generated or not. It will just become more convincing. So the harder it gets actually with forensics to tackle that. I think the source credibility have credibility networks and some way to tie information to the actual source in a secure encrypted manner. I think this will become key to preserve the information integrity. Of course, in addition to being transparent of processes, methods, what type of methods you use, what data sets you used. But yeah, so the mapping to the sources, I think that's an important part, and I think this is also what we are trying to do now with our platform, that we like in some information that consider or focus on disinformation, bias, that we really have trust scores associated with sources, and make sure that any analysis we can do in a very granular manner, either just do it on scientific literature or even a subset on scientific literature where you have particular trust in them.
All right. I think there was an interesting point in the chat somewhere about human nature, right? Because we say that mapping the sources of information provides trust, but I don't think that perhaps we can expect users to go through the original sources and double check that they are trustworthy, that the LLM is really synthesizing correctly the information. So I also wanted to ask you, as developers, if you could, well, if you put yourself on the shoes of users, um, what kind of decisions would you take with the information provided by these tools? Like how much money would you be able or would you be willing to risk with the information that is provided? Or what aspects of these tools would give you more confidence on this risk or this decision that you have to make? Because I guess that it's important that developers are also able to put themselves on the shoes of the users and to see if decisions um, are really no that they can be taken with trust or the information that is provided. Yes, Jonas?
Well, I think in many of the in the applications that we've been looking at, the digital twin assistant and the Glimpsite and the Pangea GPT, I think they are targeting a lot less making final recommendations that you would bet money on, like growing potatoes or putting up a wind farm or something, but more like there's two aspects, I think. One is easy, like saving time for people who kind of know what they're doing, who can also retrace what the agent is doing for them. A bit like coding, right? Ideally, you understand what it's doing. It just does it faster. Um, that's the one thing, and the other thing is to show what's possible. So if someone is really into growing potatoes, wouldn't know which data set, if are climate models even able to answer a question like this, then it can be an example of yes, it's possible, which maybe gives them trust in climate science to provide answers to the questions they have. But I don't think they should place all their bets on some final answer 42 if they don't know what happened in between.
So thanks. So I guess we are also discussing what then are the users of these tools, right? Are we using these tools as co-pilots of our own processes? So, for example, let's say that a climate scientist wants to quickly assess whether some data is available, how to process it. So it would be a bit like vibe coding, but with these kind of tools, right? Like it would improve, or it would make more efficient the work of experts already. And then we have the part of the discoverability, right? So we are improving the work of experts and we are allowing experts and non-experts to discover what is available and what is possible, but perhaps we are not at the level of recommending certain decisions or certain actions. Is this how you see the current state of the art? Yes, Jonas.
I'm thinking sometimes we can also do a little more, which is to um, explain the process to reach a decision and to make that process more accessible. So, because if you even ask any model directly, any public service, whether you should do something or not, it will give you an answer, and many things will actually be quite correct because there's a lot of good knowledge that went into these. Um, but I think in these cases, we can also show how a scientist would address a question like this. Pull these sources, make these statistics, these kind of things. And that can also help people on board to this type of decision making that's based in data.
Yeah, absolutely. So these tools have a very interesting educational aspect to them, right? That they can right now reason, they can show you the process, and you can learn from it. I'm reading the chat, and there's some interesting questions as well for you. I will start with the bottom question from Christine. So she's asking about fitness for purpose information, and which we have mentioned, right? But she's asking what concretely should they contain and who should provide this information? So people having used the data in some context or rather data providers. So I guess this is perhaps one of the bottlenecks that you're finding right now, right? You need to provide a sense of quality of the data, a sense of fitness for purpose, but who is ultimately going to provide the training data for that? I don't know if you have any comments about that. I guess this is an open question, which is very difficult to answer, right? Even scientifically, when do we say that we have agreed on a certain procedure and that is standardized? Um, yes, Jonas.
I think one thing that's nice with LLMs is that it can interpolate in semantically, right? So I think sometimes uh, I think the like real experience from real people is still the gold here, the gold nuggets. But if someone did a specific type of fitness for purpose analysis, fitting it to a different use case and bringing it up, maybe adapting it and judging its applicability to that other use case. I think that's the type of help we can get. But I think to answer the question, the provider of this data is still need to have some authority as well. And yeah, so this needs to be tightly curated by experts.
I don't know, David, or even do you want to add anything to that about additional information perhaps that we need from data providers perhaps to improve these tools, these agentic tools, to make data, I don't know, more complete so that we can also provide better recommendations.
Um, I just can give you an example based on the Pangea GPT experience and mainly on the Pangea. So to most of the data sets, there's like 100,000 data sets, but for most of them, there's some reports, scientific reports or quiz reports or something like this, and all this information reachable by the LLMs, and they could benefit from that already a lot. Another way is if there's a data set that um, have been used in some publications. Yeah, and then the proper citation and open source of this publication, because the LLMs can search for this publication, they will find it, and they will read it, and then they can use the same methods that have been applied already in this publication for the analysis of these data sets and verification of those data sets. So that's the way how at least our search do. Another thing with I've seen the question about the CF convention, and so I think it's developing constantly, and for LLMs, maybe there's a so-called MCP servers when the datasets have the like a connection. So when you can connect directly your LLM to the dataset through the MCP servers, and it means that those metadata should be extended in a way so that the LLMs can read them properly, I would say so. But this is a very like a huge topic on how we can extend it. So it's not for the like a half an hour discussion, I would say.
No,
Sorry.
perhaps it's not, but it's still, I think, an interesting observation, right? That developers are still asking for the same stuff that we were asking 10 years ago. So the more standardized we have our metadata, the more rich it is, the more, the better tools we can build, right, with AI. Yes, Jonas?
Just a brief anecdote. When we built a RAG, so a retrieval, or at least like no a similarity search, so fuzzy matching on parameters, we at first, in the digital twins, we at first used the parameter full descriptions, which sometimes was several paragraphs and sometimes was just one sentence or maybe even nothing. And that gave us a lot of false hits because in some paragraphs they explained even what you could do with the data, or they even mentioned alternative data in the same description and so on, right? So, and that, of course, when looking for similar data sets based on these descriptions, gave a lot of false positives. So, beyond, so for CF conventions, if you look away from these very like structured things like variable names or something and units, but for descriptions, I think if there are constraints on how these should be structured and what they should contain and what not, that is really helpful, especially for this. Right, we mentioned the agents now can't have all the information embedded. They need to look them up on demand, and then the more homogeneous this information is, the better. So CF conventions, please.
Yeah. I will look, well, I would like to talk about something else as well, which is the nuance of science, right? The complexity and how this complexity or disagreement is perhaps handled by these agents. Let's say that a user is asking for a product to be downscaled or a certain report to be synthesized. So how capable are these models to provide a sense of, okay, maybe the community doesn't completely agree on the methodology to do something. Here are some alternatives. Here are the sources. Are these tools capable of having this conversation, right? Because they, in this sense, they would really add value to newcomers to the field because they wouldn't get a straight answer of, hey, if you want to do that, here's your process, just run it. I know what's your feeling about this situation? Yes, go ahead, Stephen.
Yeah, as Jonas mentioned in his presentation, I will come back to the example. Sorry. So Jonas mentioned the skills in the chatbots that like cloud code or something like this, where you basically force the LLM to do some non-usual thing that it will do automatically. And for example, you can force it to have a discussion between the agents. You can force it to have a discussion the same. So the cloud code will open 2 or 3 additional requests. Yeah, and it will to the main agent it will give some kind of different opinions. Okay, and then it depends on how you set up your system. You can ask either human or the LLM can decide itself on what kind of path it should follow. So you really can force the LLMs to find alternatives and think critically if we really need to follow this path or another one. So that's maybe, yeah. So try to answer your question this way.
So is this also perhaps not so much a problem of architecture and reasoning, but also of prompt engineering? I don't know if
It is
by
both.
allowing people to ask straight questions, you're allowing them to get straight answers, right? I don't know if there's something that can be done in this regard to avoid misuse of these tools. Yes, David.
I mean, I would say it's both. I mean, I think this was of these older, more traditional web systems is really a huge problem that they, I mean, pick so top 5 sources and then base the answer on this. And then really these more reasoning-based agentic tools really have then the ability, and I mean, for Claude or ChatGPT, you see this often that they get some knowledge for some or information on some hypothesis and then start to verify this. So, okay, I have now this hypothesis, now I search for additional sources. Are there any opinions that don't agree with that? And this is mostly then really trained in this large-scale reasoning process, where basically kind of you, as model users, you don't have too much impact on. And you can really just influence this by prompting. So kind of in the system prompt say, yeah, basically for hypothesis verified, find alternative sources, but there you're kind of really dependent how well this then really works in the reasoning process of the model. Or you really have then to more hand design some workflows that do this more explicitly. But there you then also run into issues that this might not be as dynamic or intelligent if it would be kind of properly trained into the model. And then would probably also start to do this for things that are very clear and would start to waste a lot of compute. So short take, you can do some things by prompt engineering, but best case, maybe it could be solved at the model level.
Yeah, I let Jonas continue with the discussion then.
Thanks. Yeah, I was just reminded of the validation approaches that we saw in the presentations earlier, right? Where to I think what was it called to assess the faithfulness of a claim, you decompose a statement into individual claims because just feeding these large blocks of text into checks like can end up anywhere, but you can get a lot better hit rate when you decompose things. And I think for your example, Xavier, that you would actually compare different scientific approaches, I think we would really need to decompose them first in a way that they become comparable. And then you can put different agents to argue with each other, all kinds of things, but right, but you need to structure the information more consistently than it would be when you just compare 2 papers and feed them into two sessions or so, I think. And that's really interesting. Also, there was a question in the chat. Can we, or in the on Menti, can we reuse approaches across the community? And I think it would be amazing if someone built a database that digested scientific literature for climate and into which approaches they took, right? Maybe even on specific subjects and compared and then that type of a body of knowledge would become available to more systems. Just only need someone to.
I've been told that there have been some hands raised in the audience, but I was not able to see it. I'm very sorry. Christine, I was specifically told that you raised your hand. I don't know if you want to intervene directly.
Not sure if it's still the right point in the discussion to do so. I had some comments on what was said on the fitness for purpose information. So you, Ivan, I think you mentioned that it would be good to just have DOIs to peer-reviewed publication who have used the data in some context. But that would then mean also that it should be possible to also consistently change this metadata information, because data, new applications are coming up, and somebody would also, there also needs to be a filter, because sometimes we read these publications and you'd better use another data record for this and those sort of things. So there would need to be some regular reviews of metadata then as well, if this is taken seriously.
Yeah, thanks. Ivan, go ahead.
Yeah, I mean, but I'm a little bit skeptic about that. You can review like several hundred thousands, metadata sources. So, but what I'm trying to say is that every new publication that came out on open source and that the LLM can reach, and if this publication uses this data, yes, so it's like a other way around. So we have the data set, and then we continuously like searching for the new publications and adding it to our racks. And then for a certain question, if we came to this publication, then we know, okay, we can use this data set, right? And it's good one. Or other ways around also, we want to use this data set. Okay, let's search through the rack and find what kind of relevant publication we can find. And then if you have some kind of links between the data sets and the new publications, it works. So you don't need to really update the metadata all the time, I would say. But for example, I think I'm not sure, but a lot of databases, they are updating the metadata, not the metadata of data sets, but they add like, okay, this data set was used there and there and there, and then, but that's what they're also very helpful.
Yeah. Christine, do you want to reply to that? Or are you
No,
happy with the
it
answer?
was just basically confirming my view and what we're discussing here at UMETSAT as well. So we have we have an internal library here who helps us scan peer-reviewed publications on an annual basis to see where have data records that we provide been used and where the DOI has been cited. And we do our best to scan through. Of course, this will always be incomplete, but have a database available then also on our side, and this just reinforces if we want to make our data useful and also used by IML tools, that they are used in peer-reviewed publications, and that are probably also peer-reviewed publications, say only on the data record themselves with proper DOIs and then linkages to those.
Yeah. Now that Christine has intervened, she just reminded me of a topic that we were discussing during an interview, and it's actually the democratic discoverability of data sets. And you have shown some tools that are targeted towards some data sets. So, I mean, your database is kind of constrained. For example, Destination Earth or the climate data store data sets. But is this clearly communicated to the user? And if it's not, would it be possible to build a tool that acknowledges all data sets available in the globe? So, for example, data sets from Copernicus might be more easily findable than from other providers, but is this fair? Is this how it's supposed to be? I don't know. Ethical questions here, but you as developers, how do you see this challenge of not constraining the data set, but allowing the agents to find it in the internet, I don't know, or other databases. I guess, Christine, the question is too difficult. It's definitely challenging. Yes, Jonas.
I can just try it. I think it again comes back to the question whether we have somehow similar ways of presenting data sets, right? And if they are, like anyone can mint a DOI nowadays for some publication somewhere, so they don't even need to go through some of the bigger journals or you publish things on archive, right? So I think it's actually not that hard to bring your data sets and publications into the same search engines as the big publishers have. And then maybe it's really about making sure that that data set, that metadata is good enough. I would hope that that's actually quite democratic nowadays to bring in new sources.
Yeah, thank you very much. So we have reached well, I mean, the end of this session, unfortunately. But the discussion was very interesting. I hope that at least if there were stakeholders in the room, they saw that these people here are working really hard to bring new possibilities to the field. They have challenges, but the benefits are also plenty. And I think, well, I mean, I hope that you value the honest discussion that we had here, that we presented um, examples of what we can do and what we might be able to do with the help of of other initiatives. But we also presented limitations in an honest way, and for that, I also thanks a lot the participants and the panelists here. So thank you very much. And with that, I would like to close now the second day of the web festival. Tomorrow we continue as well, so it's not with AI, it's other topics related to the standardization of climate services, and maybe you can also find that interesting. So again, thank you very much for to the speakers and the panelists. You really helped this making possible. So thank you very much again.